Hello, this is Dr. Brown, and in this video we're going to go over some of the concepts you need to understand in order to work problems on test 4. We will look at a number of problems that uses some new concepts that we picked up in the last chapter here. Before we work any problems, we're going to look at some new trig functions. First is the law of sines, and it says if you, for a triangle with sides A, B, and C, with opposite angles A, capital B, and capital C, that sine of A over A equals sine of B over B equals sine of C over C. The interesting thing about this is, suppose you know side A, angle A, and angle B. Notice that you've got an equation here with one unknown, and you can solve for B. For instance, if you cross multiply, you get that B sine of A equals A sine of B. And if you need to solve for B and have all the other variables, that B is equal to A sine of capital B over sine of capital A. Similarly, looking at all the other equations that you have here, depending on what sides and angles are given, if you have three of the unknowns, or three of the variables and just one unknown, you can always solve for the other unknown. The next thing we're going to be using is the law of cosines, and this is a special equation that corrects, I would say, the Pythagorean theorem. If you have a triangle and one of the angles is not a 90-degree or right triangle. For instance, if you have sides A, B, and C, C squared is equal to A squared plus B squared minus 2AB cosine of C, where C is the angle between the two sides A and B. Notice that it looks exactly like the Pythagorean theorem, except it has this correction term, minus 2AB cosine of C. And notice if C is a 90-degree angle, cosine of C equals 0, and the formula reverts back to the common Pythagorean theorem that we know, C squared equals A squared plus B squared. Now you can rewrite all of these equations and solve for cosine of C or cosine of B or cosine of A, and this is a very handy formula to use if you have all three sides given and want to calculate any of the angles. For instance, cosine of C is equal to A squared plus B squared minus C squared divided by 2AB. So these are going to be coming in very handy, and you need to work a number of problems so that in a given situation you will use the correct formula. Now, the last things we're going to be looking at is finding the area of triangles. And you already know that the area of a triangle is equal to 1/2 the base times the height. But we're going to have some other formulas here that will be very easy to use to find the area of a triangle. One is that the area of a triangle K is equal to 1/2 times AB times the sine of the angle between A and B. In other words, if you had an A and a B and the included angle C, the area is 1/2 AB sine of C. Then finally, if you have all three sides of a triangle, you can find this area by this formula here, which is the square root of S times S minus A times S minus B times S minus C, where S is just 1/2 the sum of all three sides. Very powerful formula that was discovered by a person named Heron. So now we're going to start working some problems. Here we're given two sides of a triangle, B and C. So let's draw a triangle. And you got the included angle A. We want to calculate what the altitude H is, or the height of the triangle is, from B to side C. Now you always need to draw a picture of the triangle you're trying to solve. Otherwise, you can't keep up with everything. So we have angle A, angle B, angle C. I'm going to go ahead and label sides. We're not going to necessarily use all the sides. The side A is always going to be opposite angle A. Side C is going to be opposite angle C, and side B is going to be opposite angle B. And we want to find the altitude H from angle B to the side B, so we want to calculate this H, the height of this triangle. Notice that this triangle is a right triangle, and we can write down that H divided by C, that's the opposite over the hypotenuse, is equal to sine of A. So very quickly now we can cross multiply and say that H is equal to C times sine of A. So the answer here is that the H is equal to C times sine of A. Now we want to decide whether the following statement is true or false. In a right triangle, if two acute angles are known, then the triangle can be solved. To solve the triangle means that you can find all the angles and all the sides. Let's go ahead and draw a picture of a right triangle. A, B, C. Side A, side C, side B. If the two acute angles are known, can you find the other sides? Well, we know all the angles, C, A, and B, but notice if we don't know any of the sides, we could not solve for any of the other sides. For instance, you could have this triangle be exactly the same size, a similar triangle with A, B, and C, but it could be a lot smaller. So unless you know one of the sides, you cannot calculate and solve the triangle. So the answer is false, because solving a right triangle requires knowing one of the acute angles, A or B, and a side, or either or else two sides. Problem 3, in a right triangle, if the length of the hypotenuse is 10 and the length of one of the other sides is 6, what is the length of the third side? So right now we've got a right triangle. Always draw a picture. A right triangle, angle C, angle A, angle B, side A, side B, side C. And we're told the hypotenuse is 10. And the length of one of the other sides is 6. Let's say, suppose A is 6. What is the length of the third side? B. We know here we can use the Pythagorean theorem because it's a right triangle. So we say A squared plus B squared equals C squared, which means that 6 squared plus B squared equals C squared. So B squared is equal to 100 minus 36 equals 64. So B is equal to the square root of 64, which is 8. So our answer here is 8. Here we've got theta is an acute angle, and we're given an equation that tangent of theta equals 2/5. We want to solve for angle theta. Well, if tangent of theta is equal to 2/5, we can take the inverse tangent of both sides of this equation equals inverse tangent of 2/5. Inverse tangent of theta is theta. So theta is equal to inverse tangent of 2/5. And put that in your calculator, and you get theta is equal to 21.801 degrees. And we would write this as 21.8 to 1 decimal place. Notice it's asking us to find the answer in degrees, so the calculator has to be in the degree mode. Be sure to watch your calculator and have it in the correct mode. Here we want to solve the right triangle. A 7, B is 3. I would label these, and we want to find C, A, and B. First of all, C squared is equal to A squared plus B squared. So C squared is equal to 7 squared plus 3 squared equals 49 plus 9 equals 58. So C is the square root of 58. If you calculate this to do 2 decimal places, it will be 7.62. Notice now, there are several ways to figure out what the angle is. Let's look at the tangent of B is equal to 3/7. So B would be equal to the inverse tangent of 3/7 equals 23.198. To 2 decimal places would be 23.20. And then finally C, we can get by just subtracting B from 90 degrees. So B would be 90 minus 23.2. Equals 66.8 degrees. And notice that that answer is answer D. 7.62 for C. Notice the angle we just calculated was angle A, where we took the 90-degree angle that makes up A and B and subtracted B. So excuse me there, the A is 66.8. Here we have an obtuse triangle. We want to solve the triangle. We're given that B is 4. We're given angle A is 25 degrees. Angle B is 25 degrees. Angle A is 120 degrees. And we need to solve for C and A. Notice that immediately angle C is going to be 180 degrees minus 25 degrees minus 120 degrees equals 35 degrees. So we have all 3 angles now. And we have a side B. So let's use the law of sines and use sine of A divided by A equals sine of B divided by B. Notice A is 120 degrees. Little a, we don't know, but we know B, angle B is 25 degrees. And we know that side B is 4 inches or whatever the 4 is. So we have one unknown here. We can solve for A by first cross multiplying and know that A sine of 25 degrees equals 4 sine of 120 degrees. And A, therefore, is 4 sine of 120 degrees divided by sine 25 degrees. So A is equal to 8.19. Now, to solve for C, we can use that sine of B over B equals sine of C over C. So now we can plug this into sine of B. B is 25 degrees divided by B, which is 4, equals sine of C. C is 35 degrees divided by little c. So now we can solve for c by cross multiplying and get c sine of 25 degrees equals 4 sine of 35 degrees. So that c is 4 sine of 35 degrees divided by sine 25 degrees. Put that in your calculator and you get 5.43. And looking at our answers, C is 35, A is 8.19, and C is 5.43. So it looks like our answer is answer A. Now we have an application here where a cruise ship is going at a speed of 10 knots, sailing from San Juan to Barbados, a distance of 600 miles. Turns out there's a tropical storm, so the captain heads out in a direction 34 degrees off a direct heading to Barbados. And he maintains the 10-knot speed for 12 hours, after which the path becomes clear and he wants to make a turn here. So that he will be then headed directly to Barbados. So we want to find out through which angle should the captain turn to head directly to Barbados. And once the turn is made, how long will it take the ship to reach Barbados if the same 10-knot speed is maintained? So let's do some things here. Let's call this angle C. Let's call this triangle here B, angle B, and this angle A. So this side becomes C, this side becomes B, and this side becomes A. In order to find out how long it takes to get all the way home from point B, we need to know side C. And for that, we're going to use the law of cosines. And let's go ahead and start working the problem. The law of cosine says C squared is equal to A squared plus B squared minus 2AB cosine of C. So C squared is equal to A squared. What is A going to be? A is how far the boat went when it first started off. And he goes for 10 knots at 100 for 12 hours. So A would be 120 miles. We already know that B is 600 miles. So we get A squared is 120 squared. B squared is 600 squared minus 2AB, which is 2 times 120 times B, which is 600, cosine of 34 degrees. Now, what most people generally do is just put all of this in their calculator and get C squared and then calculate the square root of C squared, which is 504.993653. We'll round that off, of course. And now we can find the time it takes to go this last 504.99 miles. Because the distance is equal to the rate times the time. The distance is equal to 504.993653. You don't have to carry it to that many places. It's equal to the rate, which is 10, times the time, which is T. So T becomes 50.4999, which is rounded off to the nearest decimal, would be 50.5 hours. So the time it will take for the ship to reach Barbados is 50.3 hours. And now we need to find the angle. So if we can find angle B, we can subtract that from 180 degrees, and that will be the angle that the captain must turn. To find angle B, we're going to use the other version of the law of cosines, which says that B is equal to inverse cosine of A squared plus C squared minus B squared. Have these formulas handy. Divided by 2AC. So B is inverse cosine plug in for all these terms. A squared is 120 squared. C squared is 504.99 squared minus B squared, which is 600 squared, divided by 2AB, which is 2 times 120, times 504.99. And when you plug that into your calculator, you get that B is equal to 138.364 degrees. What you should do is be plugging all of these into your calculator as you watch this video and see that you can manipulate the calculator like you should be able to. Now, that means that this angle alpha here, which is the angle the captain should turn, is going to be 180 degrees minus 138.364 degrees, which turns out to be 41.635 degrees, which is 41.6 rounded off to the nearest degree, 1/10 of a degree. So the angle is 41.6. Now number 8, we want to solve this triangle. I'm going to go ahead and label. This is side A. This is side B. And this is side C. Looks like we need to find C, and then we'll need to calculate the other angles. So to find C, given that we have B is 6, we write down that C squared equals A squared plus B squared minus 2AB cosine of C. Plugging in all this, we get C squared is equal to 5 squared plus 6 squared minus 2 times A, which is 5, times B, which is 6, times cosine of C, which is 105 degrees. And then calculating C squared and then taking the square root of that, we get 8.748, which we'd round off to 8.75 to the nearest 100th of a degree. So we have A, B, and C. Let's now calculate angle A. Calculate angle A, which says that cosine of A is equal to B squared plus C squared minus A squared over 2BC. B is 6, C is 8.748 squared minus A squared, which is 5 squared divided by 2 times 6 times 8.748. So cosine of A happens to be 0.83378. And A is equal to the inverse cosine of 0.83378, which is 35.51 degrees. And so now the other angle, the simplest is to subtract it. Subtract A, and then C, and that will give us B, which turns out to be 41.4896 degrees, which would be 41.49 to the nearest hundredth of a degree. So our answer is C. C is 8.75, A is 35.51, and B is 41.49. So that solves that triangle completely. Number 9, we want to find the area of this triangle. And because we have two sides and the angle between them, we're going to use a formula that it says the area, K, is equal to 1/2 the product of the two sides times the sine of the angle between them, which is sine of 25 degrees. And this is equal to 3.80. So it's answer C. Number 10, we're given the dimensions of home plate of a random baseball field, and looks like this. What I would do here is break this up into a triangle and a rectangle. And the area of the rectangle is just 8.5 times 12 equals 120 square inches. And the area of the triangle, we've got a triangle here with all three sides given. So if we say this side is A, this side is B, this side is C, we can use Heron's formula, which says that the area is equal to the square root of S times S minus A, S minus B, S minus C. And S is going to be A plus B plus C divided by 2, which is 11 plus 11 plus C, which is 12 divided by 2, which is equal to, if you add it all up, divide by 2, is 17. So S is 17. So now, very simply, we can calculate the area of this rectangle by plugging in S is 17. S minus A is 17 minus 11. S minus B is 17 minus 11. And then S minus C is S minus 12. Put this in your calculator and you get 55.317. So the total is going to be 120 plus, let's round this off to the nearest hundredths, would be 55.32, which adds up to 157.32 square inches is the area of the home plate. 157.32. Now here we want to find the area of the segment that's shaded in blue of a circle whose radius is 6 feet, formed by a central angle of 50 degrees. Now, notice that we have a triangle here. Let me erase something here. We have a triangle, the two sides being 6 feet, and this sector, the sector of a circle, includes a triangle plus the shaded area. So let's first calculate the sector of the circle. And this area is going to be 1/2 r squared theta. You remember that from when we first started looking at unit circles and circles. And that would be 1/2 r squared, which is 6 times 6, is 36, times theta, which needs to be in radians, so we need to take the 50 degrees and multiply by pi radians for 180 degrees. Notice our degrees cancel out. And this is equal to 15.7079 square feet. It's a sector of a circle. To calculate the shaded area, we need to take the area of the triangle. Triangle area is going to be 1/2 the product of the two sides, which is 6 times 6 times sine of 50 degrees, sine of the angle between them, and we get 13.7887. So the blue area that we want to find is the entire sector minus triangle, which is 13.7887, equals about 1.9191, which I would round to 1.92 square feet, which is 1.92. So that's the answer. Here we've got a triangular building, which I haven't really seen a lot of you, but you'll see these in some cities. It's bounded by 3 streets, and I don't know what I'm drawing this to scale. One side is 94. Let that be A. Another side is 192. And the second and third street is 176. We want to approximate the ground area covered by the building. So we need to know K, or the area is going to be the square root of S, S minus A, S minus B, S minus C, Heron's formula. And to calculate S, we take A plus B plus C divided by 2 is 94 plus 192 plus 176 divided by 2 is 231. Now we're ready to calculate the area K, the square root of S, which is 231 times 231 minus 94, 231 minus 192, and 231 minus 176 equals 8239.10 square feet. So 8239.10 square feet is the area. Now the next problem, pretty simple one. We got a triangle, 2 sides given, and the included angle. Notice you need to always be check and make sure that the layout is such that you have the included angle. This is A, B, C. We're given that B is 2, C is 3, and A is 70 degrees. So we do have 2 sides in the included angle. So the area is equal to 1/2 3 times 2 times sine of 70 degrees equals 2.82. Goodness, I put too many easy ones in here. Here again, I want to find the area of the triangle. K is equal to 1/2 times 1 times 4 times sine of 70 degrees is equal to 1.88 square units. Next problem, we want to solve this triangle. And this one, you don't exactly have to draw it out, but let's do it. A, B, C. A is 5. B is 3. C is 4. We want to find all the angles. So here we go to the law of cosines, and we get cosine of A is B squared plus C squared minus A squared over 2BC. It equals 3 squared plus 4 squared minus A squared, which is 5 squared, divided by 2 times 3 times 4. Notice that this is equal to 0. So A is equal to the inverse cosine of 0, which is 90 degrees. So we really know that this is a 90-degree angle. And to find the other angles, we use B, cosine of B is equal to A squared plus C squared minus B squared over 2AC, which is 5 squared plus 4 squared minus B squared, which is 3 squared, divided by 2 times 5 times 4. This equals 0.8. So B is equal to the inverse cosine of 0.8, which is equal to 36.869, which we'll round off to 36.9. They're asking here for 1 decimal place. And then finally, C, just take 180 and subtract the other two. One's 180 minus 90 minus 36.9 is equal to 53.1 degrees. So our angles are 90 degrees, 36.9, and 53.1. Now the next problem is a practical application problem, which you always need to draw a picture. We got 2 hikers on the opposite side of the canyon. Each stand precisely 525 meters above the floor. Here's this canyon. They're 525 meters above the floor of the canyon. And they see an object or a landmark on the canyon floor. Let's just say it's right here. So they spy the object. And we're told that the angle of depression from each hiker to the landmark is 37 degrees. This is the angle of depression. And the other one is 21 degrees. How far are the hikers Well, looking at the geometry here, this angle and this angle would be the same because these are parallel lines. So we got these angles here, and this angle here would be 21 degrees. And so we want to find out how far away the hikers are. Well, the distance of the hikers is x plus y, where x and y are the legs of this right triangle. So now we can say that 525 over x is equal to tangent of 37 degrees. And 525 over y is equal to tangent of 21 degrees. So we can solve the first one for x and the second for y and add them up. Notice that x tangent of 37 degrees equal 525, and y, cross multiplying, times the tangent of 21 degrees is equal to 525. So x is equal to 525 divided by tangent of 37 equals 696.6985. Everybody should do this themselves. And y is equal to 525 over the tangent of 21 degrees, which is 1367.6717. So the distance between the hikers is x plus y. Adding these up, you get 2064.37. So round it off to the nearest meter is 2064. Okay, solve the triangle. We're given three sides, A, B, C. This is a pretty simple drill to do this one. Still going to draw the triangle. But this is pretty straightforward. A is 15, B is 15, and C is 13. So we start out, cosine of A is B squared plus C squared minus A squared over 2BC, which is 15 squared plus 13 squared minus 15 squared over 2 times 15 times 13 equal 40.4333. So A is equal to inverse cosine 0.4333 is equal to 64.3 degrees. Let me erase that, get this straight. degrees. Cosine of B is A squared plus C squared minus B squared over 2AC is 15 squared plus 13 squared minus 15 squared over 2 times 15 times 13. And should be have seen that since we have two sides here the same, the angle cosine of B is going to be the same thing. It's going to be 0.4333. So again, B inverse cosine of 0.4333 going to be 64.3 degrees. And finally, C is equal to 180 minus 64.3 minus 64.3 is 51.4 degrees. And that is answer D. Here we want to find the length of the span of a proposed ski lift from angle A to angle B, which is L. The surveyor measures the angle DAB to be 25 degrees and then walks off a distance of L equal 1,600 feet. And measures the angle ACB to be 15. What is the distance from A to B? So we want to find this distance. So let's label everything we know. We have B, well, B is equal to 1,600. We have A is equal to 180 degrees minus 25 degrees equal 155 degrees. And B then is going to be 180 minus 15 degrees minus 155 equal 10 degrees. So we have all the angles of the triangle, and we have side B. So we want to find side C. So let's use the law of sines, which says sine of B over B equals sine of C over C. B is 10 degrees, we know that B itself is 1600. We know that angle C is 15 degrees. And we want to find side C. So we have an equation with one unknown, and we cross multiply and say C times sine of 10 degrees equals 1600 times sine of 15 degrees. So C is 1600 sine of 15 degrees divided by sine of 10 degrees equals 2384.77. So they ask for two decimal places, and that's what they get. 2384.77 feet. Now we're going to solve a triangle problem. And in this situation, we're going to find out that there could be one triangle or two triangles, depending on what the parameters are. So here it's very important to draw out the triangle. A, B, C. A is 7, B is 9, and angle B is 49 degrees. So we got capital B and little b, and then we have side A. So let's try to find angle A. And we would use a law of sines that says that sine of A over A equals sine of B over B. So sine of A equals sine of A over 7 equals sine of B, which is sine of 49 degrees, divided by B, which is 9. So we get that sine of A is equal to 7 sine of 49 degrees divided by 9 equals 0.58699. So here we need to be prepared to determine whether A could be two different angles, because let's let A1 be the first possibility, is equal to inverse sine of 0.58699, which equals 35.94 degrees. So that's A1. And now we need to figure out whether there is another angle whose sine is also 0.58699. We can look at that. A1 equal 35.94 notice there's another angle, A2, which would also have the same sign, and that would be 180 degrees. Notice that this is 35.94 also. So A2 is 180 minus 35.94 degrees. So A2 equals 144.05. Now, notice that 144.05 plus 49 degrees, if we add these up, is 193.05 degrees, more than 180 degrees. And we still don't have enough room to have angle C. So it's only going to be one triangle. And A is going to be equal to 35.94 degrees. And C is going to be 180 minus 49 minus 35.94. C then is going to be 95.06 degrees. And now we can find side C by using sine of C over C equal sine of B over B. And sine of 95.06 degrees divided by C equals sine of B, which is sine of 49 degrees, over B, which is 9. And solving for C, cross multiplying, we get C equals 9 sine of 95.06 degrees divided by sine of 49 degrees equals 11.88. So as we said, we've got one triangle. C is 11.88. Angle C is 95.06. And angle A is 35.94. So it's one triangle. What you want to bet, we're going to do one in which you have two triangles. And for this, the numbers have to be set up just right so that you have room for two triangles. So here we're going to draw out this triangle, A, B, C. A is 4, B is 2, and angle B is 15 degrees. So let's start out. Make sure we have enough room, because we just might come up with two triangles. Let's start up here. Sine of B over B sine of A over A, which gives us sine of 15 degrees over 2 equals sine of A over 4. So cross multiplying, we get sine of A equal 4 sine of 15 degrees divided by 2. And that equals 0.51763. So A is equal to inverse sine 0.51763. We're going to call this A1, and it equals 31.17 degrees. Now notice A2 would be equal to 180 degrees minus 31.17 degrees. This would be the other angle that has the same sign, and that is equal to 148.83 degrees. So now, let's calculate C1 is going to be 180 minus 15, which is B, minus 31.17 degrees equals 133.826 degrees. So we have a C1, we have A1, and of course B is 15, which would be B1. C2 would be 180 minus A2, which is 148.83, minus the 15 degrees. And if we get a positive number, it means we're right. We've got two triangles. And sure enough, C2 is 16.17 degrees. And at this point, you could go ahead and pick this because there's only one choice. It says two triangles. But to completely solve this, we need to calculate C1. So we would say sine of C1 over C1 equals sine of B over B, which says that sine of 133.826 over C1 equals sine of 15 over B, which is 2. So C1 is equal to 2 sine of 133.826 degrees divided by sine of 15 degrees equals 5.57, which is C1. Now, to get C2, we do sine of C2 divided by C2 equals sine of B over B. And remember, sine C2 was equal to 16.17 degrees divided by C2 equals sine of B, which is sine of 15 degrees, over 2. And then finally, C2 equals 2 sine 16.17 degrees divided by sine of 15 degrees. So finally, C2 is equal to 2.15. So here we have two triangle solution, and it is this. Notice that the numbers are exactly how we calculated them. C2, 215. Angle C2, 1617. A2, 148.83. And then you here see the parameters for A1, C1, and little c1. Now, I sort of like this one because this will be sort of interesting. We have an angle, a triangle A, B, C, with B being 108 degrees, B being 5, and A being 23. So we want to solve the triangle. That means finding C, A, and C. Well, since we have everything we need to know about B and a little bit about A, let's use sine of B over B equals sine of A over A. That's sine of 108 degrees over B, which is 5, equal sine of A over 23. So we can get, by cross multiplying, 5 times sine of A equal 23, sine of 108 degrees. So sine of A equals 23 over 5 times sine of 108 degrees. And when you get that, you get 4.37. Now, everybody knows that the sine of an angle can't be more than 1, so this means no triangle, no solution. And your work is done on this one. And then finally, the last problem is going to be a law of cosines problem. And I put this up because we just got over with the masters. Here, a golfer hits a tee shot that lands in the rough 140 yards. And his ball lands here, and he wanted to go here. And as he looks towards his ball, he measures 125 degrees towards the ball. Then he paces 40 yards to the ball. how far is the ball from the center of the green? And this angle here is 125 degrees. We want to know what this side C is. So this is going to be side C we want to find. This is angle C. We'll let this be A and let this be B. We know A and B, so we know that C squared is equal to A squared plus B squared minus 2AB cosine of C. So C squared is equal to A squared, which is 140 squared, plus B squared, which is 40 squared, minus 2 times 140 times 40 times cosine of C, 125 degrees. So taking the square root of C squared, after you calculate C squared, you get C is equal to 166.2. So the ball is 166.2 yards from the center of the green. And that is the last problem.